Hello, so in this video I'm going to give some examples of using the derivation system to produce models of invalid arguments. So we'll look at 3.1.18.1. We've seen this argument before, but that's fine. So we have the premise sum x fx and not gx, and the premise sum x gx not fx, and the conclusion for all x fx or gx. So we want to use the derivation system to show that this to help us figure out what model shows this argument is invalid. So if we go down here, we see, oh, here's the derivation button. I wonder what that does. Well, if we click it, what it does is it opens up a window in the derivation module with that argument. So what do we want to do? Well, we'll say show the conclusion, and then we want to make the indirect assumption, and we bring in our premises. And now we want to use the EI and UI method with these sentences to produce a witness set. So we can do 2qn, we'll do 5ei to I, 4ei to j, and 3ei to k. And let's see, 6 we want to do a De Morgan's too. And now all we need to do is produce, these are the witnesses for our three extensions. So all we need to do is produce a model in which these three are true, and we'll have a model in which these are true, and this is true, and so so the conclusion is false. So we'll have true, true, false. So, well, that's pretty easy. We want to be looking at both of these at the same time. So we're going to do, now one thing we can do actually is I suppose we can copy these over into the work area. So we have I, j, and k. So we know we want to have three elements, one for I, one for j, and one for k. And to make this easy, we're going to go through and say, okay, we're going to assign I to 0. So I'm going to go through and actually replace the i's with zeros so that I don't have to keep track of that in my head and have the computer do that for me. Okay, so now I know I need to have, did I put in a negation there? No. So we want 0 to be not an extension of f or g. That's easy, it's not already. We want 1 to be an extension of g, so there we go. We want 1 to not be an extension of f, we've already got that. We want 2 to be the extension of f, and not an extension of g. So it looks like we should be good to go. We've made this true, because 2 is in the extension of f but not g. We made this true, because 1 is in the extension of g but not f. And we made this true, because 0 is not in the extension of f or g. So these are the witnesses of this, given that there are only 3 elements in the universe, each with the value of one of those different variables we were starting with, and if we check it, indeed it works. So that's one example. So we'll just look at one more. Okay. So we have if for all x fx, then for all x gx. So if everything's a frog, then everything is green. And this says for all x, if fx, then gx. So each thing is such that if it's a frog, then it's green. So if everything is a frog, then everything is green. Each thing is such that if it's a frog, then it's green. This is indeed an invalid argument. So let's do our derivation for it. So here we have our derivation module. So we'll say show the conclusion. So we assume ID qn, and we bring in our premise. So we'll do 2ei to I, and we might as well do nc here. Now the thing is, what do we do with 3? There are universal quantifiers in there. What we do with 3 is what we would do anyway. We'd try to show and we'd assume ID. And we might as well do qn, and we do ei to j. And at this point, we're pretty much done. We've worked with our indirect assumption. We've tried to use the premise. There's nothing really more to do at this point. And so at this point, that means what we have is a witness set. We have this and this, right? And we can think about this. We can be sure that it's a witness set. This makes this false, so it makes this true, so it makes that true. This makes this true, so it makes this false, makes that false. And oh, that means this conditional has a false antecedent, so it's true. So if this is true and this is true, then that's true and that's true. In other words, that's true and that's also true. So we have a witness set. you can always verify that you have a witness set by going through those calculations and making sure, do I have enough sentences to make, do I have enough quantifier-free sentences to make the original premise and negated conclusion true? Okay, so we have two variables, so I will be 0 again, and j will be 1. Oh, and I deleted that, so that was f0 and not g0. So okay, we need to have 0 in the extension of f, and 0 not in the extension of g, and we need to have, oh, and that should be 1. 1 is not in the extension of f. Okay, good, so that should work. And indeed it does. And what's going on with this sentence, by the way, is that this says if everything's a frog, then everything is green. So that's fine. That conditional is true if it has a false antecedent. So suppose it's not the case that everything is a frog. Then the conditional is true, period. It gives you no more information. But then suppose there are also some frogs. The conclusion says, oh, they have to be green. But that's not guaranteed by the premise. The premise is already true because the antecedent is false. In the situation in which everything is a frog, then both the premise and the conclusion agree that everything is green. But in the situation where there's some things that are frogs and other things that are not, the premise is already true because there are things that aren't frogs. But the conclusion requires more. It requires that all the frogs also be green. And the premise doesn't guarantee you that, and that's why this is an invalid argument. And that's what this demonstrates. We're in a situation where we have two objects. Is everything a frog? No, there's something that's not a frog. But there is also something that is also something that is a frog, but hey, it's not green. And so this is a situation where the premise is made true by the fact that there are non-frogs, but the conclusion is falsified by the fact that there are non-green frogs. So there you go. If you have questions, let me know. I'll be having office hours on Sunday as usual, and a new homework assignment will be going up. And I'll be having some review discussion as well. So good luck with your homework. Let me know if you have questions.